Good morning to everyone. My name is Jay Sri Kiran from CAT C section. Let us discuss about common collector configuration BJT bipolar junction transistors in subtopic CC common collector configuration. Let us discuss. In this configuration, basic terminal of a transistor serves as the input, emitter terminal output, and collector terminal in common from both input and output terminals named as common collector configuration. The input applied between base and collector while output taken from emitter and collector. In common collector configuration, the collector terminal is grounded, so common collector configuration is also known as grounded collector configuration. Let us discuss about circuit diagram of common collectors. In this diagram, we can observe input is VBC, output is VEC, and current is IB. We can measure in microamps only. In output current IE, we can measure in milliamps. IC is common collector, always connect to ground. B is base, E is emitter. The incoming current or base col- conduct collector and outgoing current is emitter always. Sometimes common collector configuration is reflected as emitter following voltage following coming the ammeter CC ammeter of the CC configuration mostly used as voltage differ. In this supply voltage between base and commutator denoted by VAC, input voltage between emitter and collector is denoted by VEC. In this configuration, input current denoted by and output current emitted current denoted by IC. The common collector amplification has been input and low output has gain is current again. The power again commutator collector amplifier medium to full wave transistor with CC configuration. We need to step characteristics in this output characteristics and input characteristics. Let us discuss about input characteristics. Input characteristics describe the relation between input current, base current IB, and input voltage, base voltage VEBC. First, draw a vertical line and horizontal line. Vertical line represents y-axis and horizontal line represents x-axis. In input current, both current IB taken along y-axis vertical and input voltage base voltage VBC taken along x-axis horizontally. To determine input characteristics, output voltage VEC is kept constant at a 3. Input voltage VBC increasing from 0 to volts. Different voltage levels. From each level, input voltage VBC conveys input IB node. A current and drawn between input current IB and output voltage VBC, constant voltage VEC. Let us discuss about input characteristics graph. We can see x-axis VBC voltage. We can see y-axis IB in measure in microamps. VEC is equals to 3 volts. VEC is equals to 5 volts. In output voltage VEC increasing from 3 volts from voltage level. Example 5 voltage, while increasing output voltage VEC, increasing voltage VBC kept constant voltage. After we kept voltage VEC constant at 5 volts, in input voltage VBC increasing from 0 volts, different voltage level. From every level voltage input VBC correspondingly input of IB noted. A curve drawn between input current IB and input voltage VBC constant output voltage V is equals to 5 volts. Let us discuss about a output characteristics. The output characteristic describes relation between output current and emitter current IE and output voltage emitter or emitter collector voltage VEC. First to draw a vertical line and horizontal line. The vertical line represent y-axis and horizontal line represent x-axis. The output current emitter IE is taken along y-axis vertical and output voltage emitter collector voltage VEC is taken along x-axis horizontally. To determine output characteristics, input current kept constant at a microamperes, output voltage VEC increasing 0 voltage, different voltage level. From each level output voltage VEC then corresponding out IE is noted. A curve then the drop between output current IE. Output voltage V is constant, input current IB is 0 microamps. Let us discuss our characteristics graph. We can see VEC voltage in x-axis, IEMA is y-axis. We can see in output characteristics 3 regions: cutoff region, activated region, saturated region. In input current IB increasing from 0 ohms to 20 microohms, then kept constant 20 microohms will increase input current IB. The voltage output VEC kept constant at a 0 volts. After keeping input current voltage constant 20 ohm, output voltage VEC increasing from 0 voltage, different voltage level. From every level output voltage VEC corresponded to output voltage current IE recorded. A curve drawn between output current IE and output voltage VEC constant input. Region activated region of a transistors. The process of replacing I fixed value in current IB 40 microohms, 60 microohms, 80 microohms and so on. In common collector configuration, input current base current 0, output current emitter also 0. Result of no current flow through a resistor, so resistors will be cut off region. It is base current strictly increasing, output current emitter also increase. Transistors false activated region if base current heavily increasing, current flowing through a resistor have heavily increased. A result that transistor falls into a saturated region. Let us discuss about input resistance. Input resistance defined as a ratio in input voltage or base voltage VBC corresponding to change input current or base current IB, output voltage or emitter. The input resistor common collector voltage VE is kept as a constant. We can see in output voltage RI is equals to delta VBC by delta IB. VBEC is the constant. Let us discuss about output resistance. Output resistance defined as a ratio of output voltage or emitter voltage to corresponding change of a current. Emitter current I with a input current base current I kept constant. Output resistance common configuration is low. RO is equals R output is equals to delta VEC by delta IE. IB is the constant in output resistance. Current amplification pattern. The current amplification defined as a ratio output current emitter current IE change input current base current IB expand by 5. 5 is equals to delta IE by delta BE. Thank you for giving this opportunity.